Welcome back. So we have done up to question number 4. So let's see question number 5. So what is that? State the reason whether the following functions have inverse or not. So you have to see whether these functions are invertible or not. So before that, I want to revise what we mean by inversible function. So you see a function f. If you have a function f, okay. So we have a function f from a to b, okay, and g is a function from B to A. We say f is invertible if f of z is I B and g of f is I A. And this f will be invertible. You can go through the definition of invertible function. You can know that f will be invertible. F is invertible if and only if f is bijective. That is 1 1 1 1 and 1 1 and onto 1 1 and onto. Okay, 1 1 and onto. So these are the qualities of a bijective function. So you have to know that first. If it is invertible functions, if it is invertible, then it will be bijective. Bijective means what? 1 1 and onto. So whenever you have to check whether a function is bijective or not, you have to see this criteria. Okay, if it is bijective, there will be something like this. But before that, if you want to find whether it is bijective or not, first of all you have to see whether it is 1 1 and onto. If it is 1 1 and onto, then it will be bijective. Okay, so that will be the test. Okay, so you can see invertible function means what? Bijective function. That's why I have been emphasizing on this 1 1 onto. Okay, the topic 1 1 onto. We have done it 3 times. That's why, because it is very important. From that only we can see whether a function is bijective or not, or invertible or not. If it is invertible, we can find out a function like this, which goes from the codomain to domain, and that will be inverse. Okay, so let's go to the exercise now. So here is the exercise. The first exercise you see, first one is what? F is a function from 1 to 3, 4 to 10. So this is a thing. So you can see that 1 goes to 10, 2 goes to 10, 3 goes to 10, 4 goes to 10. So everybody is going to 10. So you can see that definitely this is not 1 1. If it is not 1 1, then it will be not bijective. Okay. So next 5 6 7 8 1 2 3 4. So you can see it is going from 5 is going to 4, 6 is going to 3, 7 is going to 4, 8 is going to 2. So you can see that this 5 and 7 is going to 4. So therefore this is not going to be bijective. Okay, similarly you can just see whether it is bijective or not. Okay, I'm not going to do it for you. So I'll just go to question number 6. So that f is a function from close interval 1 1 to r, and it is defined by x plus 2. And you have to show that this is 1 1 and find the inverse. So you have to find the inverse from the set this to the range of this. Okay, so we'll try to see whether it is invertible or not. Right, we'll try to find out if it is invertible. Okay, so that is the thing. So this is the question. So you have a function from this to this. Oh, close interval minus 1 to 1. So you know what is close interval 1 minus 1 to 1. So you have the number line here, you will have a 0 here, 1 will be here, minus 1 will be here. So we are talking minus 1, so it should be 1. So we are talking about all these points, okay, all the points here. Okay, so this is the function. You can see that this function is defined for every point here. So whenever you put any point from this thing, because this is not defined only the case when x is minus 2, but minus 2 is not there, so it is well defined. Okay, it is you can find out the value of every point, every function value of every point in this interval minus 1 to 1. So let's try to find out whether it is 1 1 or not. So for 1 1, it is very simple. The process remains the same. So 1 1. So what you do? Start with let f x1 is equal to f x2. Okay. So first of all, this is the thing. Now you put the value of x1 and x2 in the formula. So you'll get x1 divided by x1 plus 2. This is equal to fx2. So this will be x2 by x2 plus 2. Now you cross multiply this thing, so you will get x1 into x2 plus 2 is equal to x2 into x1 plus 2. So now you multiply this, so you will get x1 x2 is equal plus 2x1 is equal to x1 x2 plus 2x2. So here this will get cancelled. So basically you have 2x1 is equal to 2x2. Now you cancel 2, so you get x1 is equal to x2. So thus, therefore, f is 1 1. Okay, next we have to check whether it is onto or not. If it is onto, then we'll try to find out the inverse of that. Okay, so that is the thing. So let's try to do it. Okay, we have the function. So I'll write the function again here. So our function is, let me write it here. F x is equal to x by x plus 2. So this is the function we are working on. So we have to find whether it is onto or not. So we'll start with onto. So we are showing it onto because onto is going to help us to find out the inverse of that. Okay. So we'll start with let y belongs to range of f. Okay. So we are going with a point in the range of f. Okay. So I don't know what is that. So we don't care about that. So we're just taking a point here. So such that what is my aim? So my aim is to find x belongs to the closed interval minus 1 to 1 such that what f of x is equal to y. So this is my aim. So let's say this is y belongs to this. So you just for onto part you have to do a rough. Okay, a rough should be shown actually. Okay, so you have to do a rough here. Here is the rough. So you start with fx equal to y. Now you put in the value of f x. So this is x plus 2 equal to y. Now you try to solve this thing for value of x. So we'll solve it in terms of y. So we'll do it. So this will be x is equal to y x plus 2. Okay, so which is equal to x equal to xy plus 2y. So we'll bring in every term containing x to the left hand side. So this will be x minus xy is equal to 2y. Okay, so you have to see the trick. Okay, trick is very important. Now you take out x common. So this will be 1 minus y is equal to 2y. So this implies x is equal to 2y divided by 1 minus y. So you see, and this thing is valid for the range. You see, So this is the x, okay, for which we have fx equal to y. Okay, so you can just try to see it also if you want. So now you find out this. Okay, I want to find out this. So I want to find fx for this value of x. So what you will get? So this is equal to f of this value. So this is 2y divided by 1 minus 1. Okay, so if you find this, so this will be, so find this value, so this x by x plus 2, so this x means 2y by 1 minus y divided by 2y by 1 minus y plus 2, which is basically 2y by 1 minus y. So you have to solve the denominator, so LCM will be 1 minus y, so 2y plus 2 into 1 is 2 minus 2y, so 2y. Now this thing will get cancelled, this term and this term will get cancelled, so you'll get basically 2y in the numerator and denominator. You see this minus 2y and minus 2 will be carried, will get cancelled, so we get 2 here, so we cancel 2 and 2, so you get y. So you see f of this equal to this. So let y be in the range of this, then there exists x equal to 2y minus 1 by y and belongs to the open close interval this, such that f of x is equal to y. Therefore f is onto and inverse of f is what? A function from range of f to the closed interval minus 1 to 1, so that g, sorry, it should be what? Things are not working very properly. Okay, so this will be g of y is equal to, just plug in this value here. Okay, so this thing 2y by 1 minus, so you can verify that f of z is identity and g of, this is g, g of f is identity. So you just try to verify this. Okay, so this part you verify. Okay, so if you verify, then you will get it. Okay, now in question number 7, we have f is a function from R to R. It is given by 4x plus 3. So we have to show that it is invertible, and we have to find out the inverse of f. So if we want to show some function is invertible, what should be our concept? Okay, so first of all, we know that f is invertible if it is bijective. So if I can show that f is bijective, that means we have shown that f is invertible, and from the proof of onto part we can find out the inverse of f also. So how to do that? Let's do it. Okay, so here we have the function f R to R. So I want to show that this is bijective. So first of all, our first option should be 1 1. So we have to, so it is 1 1. Okay, so for 1 1 we start with the same step, that fx1 is equal to fx2. Okay, now you put in the value of f for x1, so f is 4x plus 3, so this will be 4x1 plus 3, Similarly, this will be 4x2 plus 3. So we have to cancel 3 and 3. 3 and 3 got cancelled. So you have 4x1 equal to 4x2. Now 4 got cancelled. So you will have x1 equal to x2. Thus, what? Thus, f is 1, 1. Okay. So next we have to show that f is onto. Okay. So to show onto onto, so what we have to do? Just I will write the function here. Fx is equal to 4x plus 3. So yeah, so we have to start with let y belongs to R. We have the function R from R to R. So our aim is what? Our aim is to find find x belongs to R such that f of x is equal to y. Okay. So you have to do this thing in rough, as we know that for onto part we always do this thing in rough. So we'll start with fx belongs to y, or fx equal to y. Now you put in the value of fx. So this is fx. Now you solve this for x. So this will be 4x equal to y minus 3. So x equal to y minus 3 divided by 4. Okay, so this is the thing. Therefore, let x equal to x. So there it is. Y minus 3 belongs to 4. X equal to this, such that f of x equal to y. Okay, this is the thing. Now, for inverse, now f inverse x will be what? You just put in this thing. Okay. So as I have put x here, so this variable y will change to x, then 3, and 4. This is the x inverse. So you can just find out f or f inverse of this of x. My claim is that it should be equal to x. Similarly, f inverse of f x is x. Okay. This is my claim, and you can just verify this. Okay. So you can use the definition of composition of mapping and try to verify this. So we have to show that this is invertible and verify that the function given is the inverse of this. So to show this is invertible, so we have to first show that it is 1 1. Okay, from 1 1 देखा बोला 1 1 लिखी को बोलेगा 1 1. So हम start को बोलेगा f x1 is equal to f x2. Okay, so let this is the thing. Now what will be f(x1)? This will be x1 square plus 4 is equal to x2 square plus 4. Okay, so this implies x1 square equal to x2 square. Now you take the positive square root of this 2, so you get x1 equal to x2. Okay, that is the thing. So therefore f is 1 1. So why is this? Because you see here we are taking from r plus to r plus, so you have only one root here. Okay, that I have positive root positive root here square root positive square root okay, so this is the thing. So if it is total r, then we have two options, minus kita tadi, but we cannot take minus here because in the codomain you don't have the negative thing. Okay, so for the square root here, that positive thing, negative thing. So there is no problem. Option is so this is as domain is fixed. Okay. Domain and codomain. Codomain is fixed. Okay. Next, to so that this is onto. So you start with. We'll do it here only. Onto करने को let y belongs to the codomain 4 infinity. Okay, so then what happened? So rough start with fx equal to y. Now you take give the right formula for this. So this is equal to y. Now x square is equal to y minus 4. Now x equal to square root of y minus 4. Now here you see y belongs to plus infinity plus 4 to infinity. Okay, this is pretty much this is very important because যদি y 4 के कम हो जाए এটা नेगेटिव हो जाएगा 1. So as this is going to negative, so you cannot find out the square root of that because it is not a real number. So 0 হলে কি হবে 0 হবে 0 হলে 0 হবে. So I want या যে কোনো এটা ভ্যালু থাকিলে y এর ভ্যালু 4 বা 4 কে ডাঙৰ থাকিলে x কি হবে এটা পজিটিভ রিয়েল নাম্বার হবে. Okay, so that is why this conditions are very important. Okay. So this implies what? Then there exists x belongs to R plus such that x equal to square root of 4 y minus 4 and f of x is equal to y. So যে কোনো এটা y into 4 বা 4 কে ডাঙৰ হয় তার কারণে এনেকুৱা x এটা থাকিব which is the square root of y minus 4 such that f of x equal to 1 y. Therefore f here f is onto. যেহেতু f onto হল so therefore f is what 1 1 হয় onto হয় so f is invertible. Okay, invertible আৰু ইয়াত এটা ইনভার্স দি থোৱা আছিল এটো ইনভার্স হয় না নহয় এটো তোমালোকে চেক কৰিব লাগিব যে চেক কৰিবলৈ you have to find f of f inverse এটো আৰু f inverse of f. Okay, so this is the thing. So this much you do for now, and if you have some problem you can ask me or we can discuss, okay, in the next class.